Okay. Okay, so 1/2 raised to x plus 1. What transformation is this? Excellent. Number 2 is negative 1/2 raised to x plus 1. What transformation is this? Yes, very good. And number 3, negative 1/2 raised to x plus 1 plus 4. Excellent. So we graph all of them, and we can also determine the x and y-intercepts algebraically first. So let's find f of 0. So how much is 0 plus 1? How much is 1/2 raised to 1? And minus 1/2 and plus 4. This is 7/2. So we determine 0 7/2 as the y-intercept. So now we want to find f of x equals 0. We know that the domain of an exponential is no problem, all real numbers. And negative 1/2 raised to x plus 1 plus 4 equals 0. How do I continue? How do I find x?
Which minus 4.
Indeed. Awesome. We have to move 4 to the other side. So negative 1/2 raised to x plus 1 equals negative 4. Next. Right, multiply by negative 1. So then this is 2 to negative 1 raised to x plus 1 equals 2 squared. So we realize that both sides can be presented with the same base. In this case, it's 2. So 2 to negative x minus 1 equals 2 squared. Negative x minus 1 equals 2. Negative x equals 3, or x equals negative 3. So negative 3 comma 0 is the x-intercept. Any questions here? Any questions? So we already have the x and y-intercepts. So we know where they would be. So I make myself a note, if you like, right here. And 0 7/2 is 3.5. Okay. I just picture them so I don't have to adjust later. Okay, so now in order of operations, as you told me, I will graph 1/2 to the x. Is it a decreasing function or an increasing function? Excellent. Indeed. It is a decreasing function. So this is 1/2 raised to x. Then you said to shift this 1 unit to the left, so here it is. So this is 1/2 raised to x plus 1. Then you told me to reflect it. Okay, here's my point, goes back here, or down here. So if I see, and that's, I'm happy that I remember to say this. If I see graphs that look like this, I cannot give any credit, because this is not a way the exponential function looks like. This is clearly copied from the graphing calculator, and I can't give any credit for this. So please be careful. Do not copy. I can't, this is not a test in how well we know how to operate the calculator. So please remember that. So negative 1/2 raised to x plus 1. And then you said everything goes up 4. And I know where it has to land. I know I have to show the horizontal asymptote, which now is y equals 4. And here's the graph. So this is the graph of the final function. And now I can identify the range as being negative infinity to 4. Yes, please.
We graph stuff like this in the past.
Yes.
You want us to graph every step?
Yes.
Graph this stuff.
Yes.
Okay.
Yes, please.
Do you need to graph any asymptotes? So it's, I remember when you said
Always, we always have to
Or
graph.
do you
Yes.
just need to graph the final asymptote, or
Here it's 0, so there is no mean normally, but you can show it if you like. But this is y equals 0, so when you move that, yes, 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 please.
What I'm always confused on is graphing a base function, like 1/2 x, or 2 raised to the x, or something like that.
Yeah, so 2 raised to the x, when the base is greater than 1, the function is this, and it has to cross at 0, 1.
Okay.
When the base is less than 1, it has to cross to the same point, but it's this. It's decreasing on its domain.
Okay, so when it's less than 1, it's decreasing. When it's more
When the
than 1.
base is less than 1, it's decreasing. When the base is higher than 1, it's increasing. Yes. Other questions, anyone? Okay, so let's look at log. Let's say we have f of x equals negative log x plus 4 and minus 2. What is the base function here? Right, indeed, log x. What is the first transformation? Yes, awesome. X plus 4, left 4. We should already identify the domain. We should do that right away with x plus 4 greater than 0, x greater than negative 4. So the domain is negative 4 to infinity, because that tells us immediately that x equals negative 4 must be a vertical asymptote once we identify the domain. Okay, so you told me left 4. Excellent. Number 2 is negative log x plus 4. And please remember, this is the correct sequence of transformations. If you use a different sequence, I won't be able to give full credit. It has to be in this order. Sorry. I know if you change the order a little bit, you may get the same graph. I understand, and I agree with you. But the transformations have to be presented in the order of operations for full credit. Okay, so what does this mean?
Flip with respect.
Right. Yes, with respect to the x-axis. Excellent. And then 3, negative log x plus 4 minus 2. That's it. So let's find the x and y-intercepts from the beginning. So f of 0 will be negative log 4 minus 2. I don't know what that is, so I'm going to put it in the calculator. So common log with minus, sorry. So minus common log of 4 minus 2. So I got approximately negative 2.6. So then 0 comma negative 2.6 roughly. That would be the y-intercept. And then when I set this equal to 0, I have negative log x plus 4 minus 2 equals 0. And then we get negative log x plus 4 equals 2, or log x plus 4 equals negative 2. So then this changes into an exponential equation. How do I change this into an exponential equation? 10 raised to negative 2 equals? That's it. Awesome. So 10 to negative 2 equals x plus 4, or 1 over 100 minus 4 equals x, or x equals minus 399 over 100. So that is negative 3.99. So the point will be negative 3.99 comma, of course, because we know that x equals negative 4 is a vertical asymptote, comma 0. Okay, perfect. We have everything now. 1, 2, 3, 4. I'm getting it ready anyway. And of course, nothing here. You don't have to do that. I'm just refreshing your memory on that. So you told me to shift this graph, which is increasing on all its domain, log x. You told me to shift it left 4. Fine. Great job. It is true. This is log x plus 4. Very good. Now, you told me to reflect it, so we're going to reflect it. Here's the reflected graph. Negative log x plus 4. And then we want down 2. So down 2 means that this point goes here. So here's the final graph. So this is negative log x plus 4 minus 2. Okay. So we know graphs, we know equations. Yes, please.
So I know you said I have to obviously graph out each step, but so does that mean even if we like list out each step, we have to graph it out, or because like sometimes
You're not going to have a lot of transformations. I'm not going to put too much on it. You're going to have 2, 3 at the most. You should be okay. So I think we should move on to trig now. I think that's all we have on this test. Now about domain, Yes, that's another topic, right? Domain of log. So we may have log, let's say, x squared minus 3x plus 2. So this is our function. How do I determine the domain of this function? What do I have to write? No, by the way, questions on the previous graph? Anything? No. Okay, so about log.
So inside greater to 0.
Excellent. Yes, Sarmat, go ahead. And now I have to dig deep, like 2 months deep ago. So how do I solve this? What is it? And how do
But
I-
you have to make factors.
I'm sorry?
Factors.
Very good, awesome. So, okay, x minus 1 and x minus 2. Now what?
Make the table.
Excellent. Well done. Thank you. X minus 1, x minus 2, and the product. Very good. So we have 1 and 2, 0 and 0, 0 and 0. They are both the same thing. Both have a positive slope, no discussion there. So then the positive, it would be outside. So the domain of this function then is negative infinity 1, union 2 to infinity. Well done. What if I have a ratio? What if I, instead of log of x squared minus 3x plus 2, what if I have x minus 1 over x minus 2? I use the same thing. The only difference would be that whichever is in the denominator will be undefined here, but everything is the same, right? We agree with this? Any questions on this one? About the ratio, you mean? So what if this is a ratio? I use the same table. But if I have x minus 2 in the denominator, I would have undefined here. That's the only difference. Is that clear? Perfect. Can we move on to trig now, to review trig for this test? Yes, please.
So when 2 is undefined, let's just say, we have to find like the 1.9 and then 2.1 to find out.
That is when we graph rational functions to see where the function is going left and right of the asymptote.
So then the answer would just be negative infinity to 1 as a domain.
For the ratio, you mean?
Yeah.
No. Everything will be the same. No change, except here will be undefined. And the domain will still be identical. Negative infinity to 1, union to, is that clear?
Yes, we just have to show that it's
Did I answer your question?
Yeah.
Okay. That is the only difference. If this is a ratio, it will be undefined here. Everything stays the same. Everything. The answer, yes. You know?
So we have to put both the factors in case of ratio, like the x minus 1 and
You still have to find still have to study the sign of both factors, yes, if it's a ratio. It doesn't matter. Product or ratio, you still have to study the sign.
because normally we are only concerned with the denominator. Like
Okay,
make
let's
sure
do a
different.
problem like that. Okay, hold on. So if in this case I have f of x, which is natural log of exactly what I said, x minus 1 over x minus 2, I still have to start with this. I still have to write x minus 1, x minus 2, x minus 1 over x minus 2, negative infinity 1 to infinity, still 0, still 0, still the same, everything the same. But here I have to write undefined, here I write 0, and this is still the same. So in order to have this positive, the answer is still negative infinity to positive 1, union 2 to infinity. There is no change.
So you mean the domain of product and
Yes,
domain is same?
the domain has to be stated for this expression. This expression has to be positive now. In the previous example, we had a product that had to be, or a polynomial function that had to be positive. But for this example, I have a ratio that has to be positive.
So as far as the log is concerned, if we have like the domain and the product, domain will be same for both of them? That
Yeah,
should be,
it is identical.
oh,
It is identical. I chose the same factors, that's why it's identical. If I change something here, like x plus 2 and x minus 5, the domain will not be the same. But I used the same factors from before. That's why it happened to be the same.
okay.
But if we change this into x plus 5 and x plus 3, the whole thing changes, of course. But since we have the same factors, they have the same zeros, the ratio of the product will always give us the same signs. Right? So if I divide the two negatives or multiply two negatives, the answer is still positive. It doesn't matter. If I divide a positive and a negative or multiply a positive and a negative, still get a negative. Is that okay, everyone? Okay, I wanted to continue with trig. Other than the graphs that we just looked at. I did grade your quiz. I just didn't get the chance to record the quiz, so I can give it back to you. You didn't have difficulties. I just, do I need to show another example like that? Like the one from the quiz that I'm returning. Yes?
Yes.
So every time we are asked to determine, just make up an angle for us. Any angle you'd like, you make up.
3 pi over 8.
3 pi over?
8.
3 pi over 8. That's a problem with 3 pi over 8 because we don't have numbers and we're not including chapter 9 in here, so we cannot determine and use a half angle.
We're not going to do something like that.
Yes.
Okay.
So anything that has in the denominator either 6 or 3 or 4. Anything.
Oh, okay, then.
So anything that you would like to come up with. Anything. With a denominator of
11 pi over 3.
excellent. Perfect example. So theta equals 11 pi over 3. So first we have to picture the angle. Use the method you like. The one I prefer is find sine and cosine and I'm done. The rest will follow immediately. So first of all, 11 pi over 3, this is 60 degrees. So 11 times 60 is 660 degrees. So this is more than one complete rotation, right? So it's 660. So this is 360, and I will have to continue 3 more hundred. So this is 270, right? So this is where I stop, 300. The reference angle is 60 degrees, or pi over 3. So then I know that sine theta will be the opposite of sine pi over 3. I know that cosine theta will be cosine pi over 3. And once I write this, I'm done, because everything else will follow. Sine pi over 3 I know is the square root of 3 over 2, and this is 1/2. That's all I need. And the other functions, we need another 20 seconds, right? So this will be negative the square root of 3 over 2, and this will be 1/2. So then tangent theta will be this over this, which is negative the square root of 3. Cotangent theta is this over this, which will be negative the square root of 3 over 3. Secant theta is 1 over cosine, which is 2. And so cosecant theta is 1 over this, which is negative 2 the square root of 3 over 3. So I know you like the triangle, that's fine by me. But this is a 30-second thing. Once you have sine and cosine, you don't need anything else. You just remember that the tangent is sine over cosine, cotangent is 1 over tangent, secant is 1 over cosine, and cosecant is 1 over sine. You don't need anything else. But I accept any method you like, and I'm fine with it. Yes, please.
So what if we have negative sign at the angle?
Very good. So you want a different angle?
Yeah,
Yes.
same angle like the negative sign.
Okay, so you want like this?
Yeah.
Let's say negative 5 pi over 3 or negative 5 pi over 6. I just want to choose a different angle. Is that okay? Yes?
Yeah, it is fine.
Is this good?
Yes.
Or you want something else? Just pick another.
Like the same question. with
You want the
negative-
same angle. Okay, very good. So then theta equals negative 11 pi over 3. So then sine of negative 11 pi over 3 is negative sine 11 pi over 3. And cosine negative 11 pi over 3 is cosine 11 pi over 3. And I go back to what I just wrote. I just have to change some signs. I refuse to work with negative angles. There's no need.
But if we draw this angle, we will go to
No, I will not even do that.
hopefully this.
No, because sine of this is that. I use a positive angle and I change the sign. I'm not going to do this. up to you. There's no need. Sine is odd, cosine is even. I'm done.
But that's what is graphical representation is like.
If you want, yes. If you are asked to present the graph of that angle, it's a different story. Or show. You will show this way instead of that way.
Okay.
But the problem, I should have clarified, you're right. The problem is asking us to find all 6 trig functions for that angle. I don't care. You should have to present it to see where it lands. If it lands in the 3rd quadrant, it's a different story. If it's in the 2nd quadrant, if it's in the 4th, it's a different story. But I will never ever use a negative angle. There's no need. Is this clear?
Yeah. So the sign will be positive, right?
Yes. Sine will be positive.
Okay.
Yes. Like cosine. Good. Other questions? So we know how to look at and determine all 6 trig functions. What about law of sines and law of cosines? That's pretty much it.
Can we do that?
Yes, of course. So let's choose anything with law of sines and law of cosines. I'm just making stuff up. So we'll see if we get something wrong, then we can adjust it. Okay, so we have a triangle. 2 sides are given, 15 and 17, and the angle in between, we're asked to find the opposite side. So what do you think we should do here? Any suggestions? Let's write law of sines and see if it works. So A, B, C. So sine 35 over x equals sine B over 17 and equals sine C over 15. In any proportion, you have to have only one variable. Otherwise, you have to think of a different method. No, I can't. So if I use this proportion, I have 2 variables. If I use this proportion, I have 2 variables. If I use this proportion, I have 2 variables. Obviously, it's not going to work. So then, it means that I have another option, and the only option, which is excellent. So indeed, x squared equals 15 squared plus 17 squared minus 2 times 15 times 17 times cosine 35. So please calculate this and take the square root. I want to record your quizzes so I can return them right now. It will take 1 second. Don't forget to take the square root, please. And please remember to rationalize the values of trig functions. Do we have a number for this? Do we have a number?
I'm sorry.
How much? Thank you. Thank you.
That number was just confusing.
Did you take the square root?
Yeah.
Okay. Can anyone confirm this number? Thank you.
All right. Wait, how much do you want me to round to?
2 decimal digits.
Uh,
That should be okay.
9.81.
How much?
9.81.
Did we get that? Excellent then. Good. So in this particular situation, we were not able to use law of sines. Now, if we're asked to continue and find the rest, the angles, now we can. Once we have x, we can determine the rest of the unknowns. That's not a problem. Okay.
Oh, thank God.
Okay. I just want to write it. Please give it to me. So x is approximately 9.81. Good. So let's take a look. What if we're given side-side angle? Again, I'm making stuff up, so I don't know if it's going to work. But that's okay. So 40 degrees, 10, 9, side-side angle. So this is A, this is B, this is C. Okay. So remember the side-side angle is the ambiguous case, right? So what do you expect? You either expect the triangle to exist, I have no idea, or the triangle not to exist, or excellent. Good. So let's start. You're going to write that sine A over A equals sine B over 9 equals sine 40 over 10. This proportion has only one variable, so I can go ahead and find sine B and eventually B. Right? So we cross multiply and we divide by 10. So sine B equals 9 times sine 40 divided by 10. I'm hoping that this is a number under 1, otherwise it does not exist and I'm done and I have to make up another. Okay, so 9 sine, oh, careful, make sure you are in degree mode now. So 9 sine 40 divided by 10. I hope it's, oh, it's good. So this is 0.5785. And I will determine sine inverse of the previous answer. And I get roughly 35 degrees. So B1 is 35 degrees. I have to check the other option with 180 minus 35. And that's 145. So B2 is 145. And that immediately and automatically will give us two different A's, A1 and A2. So A1 is what? 180 minus 40. 180 minus 40 and minus 35. And that's 105 degrees. But 180 minus 40 and minus 145 is a negative angle, which means the second option doesn't exist. Because that would be negative some degrees. So cross it out. So there is only one B, so and one A. So we determined that A is 105, B is 35, and C is 40 degrees. And now we want, the only thing we need to determine is lowercase a. Yes, Imran, go ahead. Okay. So, yes, please.
So for the test, you
Yes.
want us to check to see if it's possible.
If you get the ambiguous case, it's part of the problem. Yes. Yes, we have to. Yes. In the other situations, you will not have to. But if it's a side angle, side angle. If it's the two sides and the angle in between, no. Right? Okay, so let's determine lowercase a. Yes.
So at what point we have to stop in exam, like if we get ambiguous, like if we get negative angle, then we have to stop it?
Yeah, I already crossed it out. It's not possible. Because I can change 40. And if this is 145, this angle A will be negative 8 degrees.
So in exam, we have to stop at this point.
No, you have to solve the triangle. So that's why I listed the angles. I have two sides, and now I have to determine the third side. When we're asked to solve the triangle, we have to come up with 3 angles and 3 sides.
Yeah.
It may be that we have 2 options.
Mhm.
3 angles, 3 sides, and another option, 3 angles, 3 sides. But several of them repeat, because I can't, what is carved in stone, I can't change. So 9, 10, and 40 degrees are the same for both triangles, but the others may change if we get 2 triangles to work.
Okay.
Is that okay? Yes, please. Anna.
Let me try about B2 and A2.
Okay. So when we determine 35, B1 equals 35, as we showed. There is another triangle, there is another angle with the same sign, which is 180 degrees minus 35, which is 145.
And then do the same thing.
That has the same sign. Okay, so finally we want to determine the lowercase a. So lowercase a from sine 105 degrees over a equals sine 40 degrees divided by 10. So then a will be 10 sine 105 degrees over sine 40. So with a calculator, I'll determine this. So 10 sine 105 divided by sine 40. So we got that A is approximately 15.03. So law of sines, law of cosines. I can't think of anything else. We looked at an inverse with your first example, which was gorgeous. Thank you. There is nothing else on this test. Yes, please. Say it again, one more time. If it is, you're going to have the model. You don't have to do anything. You don't have to memorize any models, I promise. Yes,
Would
Connor?
there be any application of simplifying trig functions? So like if we have
Yes. So let's say we're given sine or cosine, right? I think I know what you mean. So yes, let's take a look at a problem like that.
Equation like secant squared of negative x minus tangent squared. This is a problem we just did in class, but will we have problems like that where it's like
We have to simplify the
Where-
different
yes. So fine.
Isn't that from chapter 9?
I know that was from chapter 8. That's from chapter 10.
In 10, we only looked at law of sines and law of cosines. But it's a good point you're making, so let me look at the following. So let's suppose we have tangent, or even easier, let's say cosine. We're given cosine theta equals 1/5, and let's say it's in the 4th quadrant. Can I determine sine theta? So something like this, yes. But nothing with identities, actually, because the identities are in chapter 9.
So we won't
We're
say
going to have plenty of identities on the next test. So no, but something like this, yes. So let's say we're given cosine theta, it's 1/5, it's in the 4th quadrant. We're asked to find sine, or we're asked to find the other 5 trig functions, function values. Yes, this is possible. So since this is, again, you can use the triangle, I'm fine with that. I think it's a perfect method, but for me it's waste of time, right? So this is negative the square root of 1 minus this squared. So it's negative the square root of 24 over 25, and I take the square root and I'm done. It's 4 times 6. So this is negative 2 the square root of 6 over 5. Again, but this is me. If you would like to, now I think it's more difficult with the triangle because you have to find the hypotenuse. If without the hypotenuse, you are not going to be able to find the other angle, the other trig function. But it's up to you. So that is possible. I can't think of anything else. Law of sines, law of cosines, expanding, condensing. Say it again, please. Meg?
Isn't there a way where you can solve for that using like inverse of sines? Because I remember I stayed after with you one time. Is that for?
I'm trying to think what was that with the
Because
inverse.
we replaced it with like sine.
Yeah, but that is when you do not have the number.
Okay.
It's a very good question. Let's do that. Excellent. Thank you. So what Mavis is saying is this. So we want to find, it's a very good question. Thank you. So here's an example. I can't thank you.